Hi all. In today's class, we'll have a quick revision of the topic motion. Without wasting any time, let's go to the topic. When we think of motion, the first term that we will discuss is what is motion. Suppose you have an object somewhere during an initial time of reference. After some time, it has moved slightly and it reached here. So here, with time, its position has changed. So, if an object changes its position with time, then we'll say the object is in motion. Now, whenever we say about motion, we'll use a reference point. Now, we started from here. Compared to this point, the object has moved this much far away. Now, consider a point here. The object was initially placed here. Afterwards, the object was placed here. Then the object was placed here. So, first it is this much far away. Then the object is this much far away. Then the object is this much far away from this particular point. So, we are describing the movement of the object based on this particular point. That point is called the reference point. Now, the two terms that we'll discuss here is distance and displacement. Think of an ant. The ant's initial position was here at A, and later the ant's position is here at B. The ant moved like this and reached here. So it was always changing its direction like this to reach here. Now, this complete path covered by the ant is called the distance. Think of the same case here also. The ant is moving like this and reach here from A to B. If we draw a straight line connecting A and B, then this is called the displacement. The complete path covered by the ant to reach B from A is called its distance. So distance is the complete path covered by an object. Displacement is the shortest distance between initial position A and the final position B. Since it is the shortest distance, it will be always a straight line having a single direction. But here, direction is keeping on changing. So in the case of distance, we can't say an exact direction. So we'll say there is no direction or there is no exact direction. But in the case of displacement, there is an exact direction. Direction is present. Anyway, both are measurable. We can measure this one. This complete path can be measured, and even this shortest distance also can be measured. So here, both can be measured, which means both are having some magnitude. Magnitude is present. Magnitude is nothing but the numerical value. If it is 2 km, there 2 stands for the magnitude. So in both the cases, magnitude is present. Since direction and magnitude are there, this displacement is a vector quantity. Since there is no direction in the case of distance, this is called a scalar quantity. A scalar quantity. See, look here. This one starts with V. Vector stands with V, which is like a sphere. It shows the direction. So whenever a quantity has direction, it's called a vector quantity. And think of this S. S is written like this. So it has different directions. Here it's like this, here it's like this, here again it's like this. So there is no exact direction. Such quantities are called scalar quantity. So distance is a scalar quantity. Displacement is a vector quantity. The SI unit of distance is meter. SI unit of displacement is also meter. Since both are units of length, the SI unit of both are meter. When we analyze the movement of ant here when the ant starts from here, it will go somewhere else, maybe it will reach some other area, or it can come back to the same portion also. Even if it comes back also, when we take the total distance, it cannot be 0. So distance cannot be 0. Think of that one, just keep it in your mind. Distance cannot be 0 because as we told, distance is the complete path covered by something. When it starts from here, anyway it will go somewhere else, even if it is returning back or if it's staying in that same spot also, there is some path covered by it. So distance cannot be zero. But in the case of displacement, there is something interesting. Suppose if the object started from A, it went to B, again it came back to A. So as we told, displacement is the shortest distance between initial position and the final position. Here initial position is also A, final position is also A. So the shortest distance between them, there is no actual distance, it's the same point. So here displacement can be zero. It is possible to have zero displacement, but it's not possible to have zero distance. Let's discuss about uniform and non-uniform motion. Think of an object. Object is starting from here. We are observing the object after every 1 second. Now, in the first second, when we observe the object covered a distance of 5 meters. In the next 1 second, again we are observing the object covered again a distance of 5 meters. Again, when we are observing after 1 second, it covered a distance of 5 meters. So whenever we observe, the object is covering equal distance in equal interval of time. Interval of time is decided by us. We'll be deciding a particular interval of time. Here the time decided was 1 second. So after each 1 second, when we observe the object, it's covering a distance of 5 meters. So here equal distance is covered in equal interval of time, equal time interval. Then it's called a uniform motion. Now in the case of non-uniform motion, imagine the same case. In the first 1 second, when we observe the object is covering a distance of 5 meters. Next 1 second, when we observe the object, it only covered a distance of 1 meter. In the next 1 second, it covered a distance of 10 meters. So first it covered 5 meters, then it covered very small distance, that is 1 meter, then it covered a huge distance, that is 10 meters. In traffic and all, this will happen. So in this case, the object is covering unequal distances. It's covering unequal distances in equal interval of time. Time interval will be equal because we are deciding it in equal interval of time. So if it is unequal distance, it's non-uniform motion. If it is equal distance, it is uniform motion. Now we'll discuss about speed and velocity. The equation for speed is equal to distance divided by time. Speed is distance by time. Coming to velocity is equal to displacement by time. Here we already know something, that distance is a scalar quantity which will not have direction, only magnitude will be there. In the case of displacement has an exact direction. So same way, in the case of velocity will also have a direction as well as magnitude. So velocity is a vector quantity. But in the case of speed is based on distance. Distance will not have a correct direction. Direction will keep on changing. So speed is a scalar quantity. Velocity is a vector quantity. SI unit of speed is meter per second. SI unit of velocity is also meter per second, because here SI unit of distance is meter, SI unit of time is second. Here also SI unit of displacement is meter, SI unit of time is second. This meter per second is usually represented as meter second raised to -1 in your textbook, because when the denominator comes to numerator, the sign of the power will change. So meter per second or meter second raised to -1 can be used. Now coming to average speed. Here average speed is important because, as I told you, the speed will keep on changing. It can change. So especially in traffic blocks and all, if you're taking the case of a vehicle that is there in traffic block, then you can't follow the exact speed. If there is a signal, you'll have to stop. If you are on a highway, you can go with more speed. So the speed will keep on changing. So during that time, we want average speed. Average speed is calculated as total distance divided by total time. It is simple. In the case of speed, it is distance by time. In the case of average speed, it is total distance by total time. A term total will come extra. That's it. Now, coming to average velocity, you have two equations. In the question, if they are giving you the initial velocity and final velocity, then you can just add both and take the average. So, average velocity is initial velocity plus final velocity divided by 2. If both the velocities are given, if initial velocity will represent it using letter U, final velocity V, if both are given, add both divided by 2. That's it. Suppose if this is not given, again follow the same equation here. Total displacement by total time. Instead of distance, it becomes displacement. So as you can see here, average velocity is equal to initial velocity plus final velocity divided by 2 if both the velocities are given to you, or else take total displacement by total time. The next topic is acceleration. Acceleration is change in velocity by time. Acceleration is equal to change in velocity divided by time. We know usually we use two letters to represent velocity. V stands for final velocity and U stands for initial velocity. So change in velocity, whenever we take the difference, take it like final minus initial. So here also change in velocity is equal to final velocity minus initial velocity divided by the time given. This acceleration is also known as rate of change of velocity. The term, it's called rate of change of velocity. Here the term rate came from the term t. Time, rate means time. Now change, here the minus sign stands for change. So acceleration is also called rate of change of velocity. Let's see the SI unit of acceleration. We know the SI unit of velocity is meter per second. Now SI unit of time is again second. So velocity is SI unit divided by times SI unit, that is meter per second by second. So it becomes meter per second square. This is the SI unit of acceleration. SI unit of acceleration is meter per second square. This is also written as meter second raised to minus 2. Now we have an important topic here, that is the distance time graph. Whenever we draw the graph, we take time on the x-axis. Time is always taken here. It can be in seconds or hour. Usually the SI unit is taken, that is second. Now, since this is distance time graph, the distance is taken here. Distance, it's usually represented using the letter S. Distance S. It is represented here. Don't be confused between speed and distance or displacement. In this chapter, in this topic, usually we use the letter S, small letter S, to represent the distance or displacement. It's not for speed. Okay. So here we'll see the distance time graph. Suppose in distance time graph, if you have a straight line like this, it means that whenever the time is changing, the distance is not changing. Suppose if the object is kept at a distance of 5 meters, in 1 second when we look, it is at 5 meters, second it's at 5 meters, third second it's at 5 meters. So always the object is at 5 meters away, which means the object is not moving at all. This means that the object is at rest. Object is not moving, it is at rest. Please remember. Now coming to the second graph, suppose if a graph is like this, a straight line like this, it means that whenever the time passes, the distance is also increasing. The time is passing uniformly, like 1 second, 2 second, 3 second. Same way, the distance is also increasing. 1 meter, 2 meter, 3 meter, 4 meter, like that. It means that the object is covering equal distance in equal interval of time. It's called uniform motion. We'll say object is in uniform motion. Go to the next one. Suppose if a graph is somewhat like this, it may not be exactly same, but if it is not a straight line at all, if it is something like this, it means that here initially, okay, it was almost like a uniform motion. Afterwards, the time is less, but the distance is increasing very fast. It means that the object is not covering equal distances in equal interval of time. It's not at rest also. It means this is in non-uniform motion. Non-uniform motion. Now, we'll get some information from the graph. The distance time graph always gives you the speed. Just see this graph. If I make a slope here, a small triangle here, if I take this as x and this as y, here x stands for this one. See, look here. X is actually this part. This is actually the distance. The distance divided by, if I take y, I'm just taking x by y. X is this part of the distance and y is this part of the time. Okay, so distance by time, you will get speed. So the slope of this graph, the slope of distance time graph gives you speed. It's an important point. Please remember this one. Slope of distance time graph gives you speed. Now we'll go to the next graph, that is velocity time graph. So as I told you, on x-axis we'll always take time. Time is taken here. Time is taken here. Since this is velocity time graph, velocity will be taken here. Velocity is taken here. Sometimes they'll represent it like speed also. If the object is traveling in a straight line, then its speed is same as its velocity. So it can be taken like that. Suppose your first graph is like this. A straight line parallel to the x-axis. Here it means that when the time is keeping on changing, when the time is increasing, the velocity is not changing. Here, maybe the velocity is 5 meters per second. The object is moving with the same velocity without changing its velocity or without changing its speed. It's moving with the same velocity, same speed. It means, don't be confused between the previous graph. Here, if you get a graph like this, the distance is constant. It's not changing its distance at all. Then we'll say object is at rest. But here the case is different. Here the object is moving, but moving with the same speed. It means here the object is having a uniform speed. A uniform speed. Or you can call it as uniform motion. Uniform speed or uniform motion. Now, suppose your graph is like this, a straight line like this, then when the time is increasing, velocity is also increasing, which means the speed is keeping on increasing. It means the object is accelerated. Or you can call this motion as accelerated motion. Okay. Same way, here if suppose if your graph is like this, it is opposite of acceleration. When the time is increasing, the velocity is reducing. Then it is uniform retardation. This accelerated motion can be also called as uniform acceleration because its acceleration is happening uniformly. You can see in the graph it's a straight line. Same way here it is uniformly retarded motion or uniform retardation. I can call it as uniform retardation. Now, suppose in your graph you have some lines like this, some curved lines and all, then it is non-uniform motion. Non-uniform motion. Now from velocity time graph, we'll get two things. One is, if you take the slope of this graph, as we did earlier, this part, if this is x and if this is y, x stands for the velocity and y stands for time. Velocity by time gives you the acceleration. Change in velocity by time is acceleration. So here, the slope of the graph will give you the acceleration. There is an important point here. If you take the area under this graph, this complete area, if you take this, you will get a square kind of thing here. If you take the area of the square, this complete square, then that area will give you the displacement of the object. The displacement or the distance covered by the object if it is a straight line motion. So we'll get a displacement. So we'll get two things from here. Suppose if you look at this triangle, then if you take the area under this triangle like this, then this complete area will give you the displacement. So whatever figure you get there, just take the area under it. You will get the displacement. So velocity time graph gives you, the slope will give you acceleration, the area will give you displacement. Next is the equations of motion. Newton's equations of motion. Equations of motions are very, very important. Now the derivation part is not needed for us, but we should be thorough with the equations. Before going to the equations, let's see the variables that we use to write the equations. We have u, as we told, u is initial velocity. U is the initial velocity. V is the final velocity. T, as we know, T stands for time. Now S, don't be confused with S. S is very, very important. Usually we'll be confused with this. S is not speed, it is the displacement or the distance. It is the displacement. Then small letter A. A stands for acceleration. Now using all this, we'll write the equations of motion. First one is V is equal to U plus AT. Next is S is equal to ut plus half at square. Next one is v square minus u square is equal to 2as. You can write it in different ways. You can just interchange it also, but basically this is the equation. V equals u plus at, s equals ut plus half at square, v square minus u square equals 2as. These equations are very much needed for us to move forward in this chapter and the upcoming chapters. So please be thorough with these equations. The last topic is uniform circular motion. There is something special in the case of circular motion. Here you think of an object moving around the circle, around the perimeter of the circle. So imagine like the object is covering equal distances, again equal distances, equal distance, equal distance in equal interval of time. Let the object take 1 second for covering this, 1 second for this, 1 second for this, 1 second for this. So actually this is a uniform motion. Correct, right? Uniform motion, because it's covering equal distance and equal interval of time, and it's going around a circle. So we can call it as uniform circular motion. This is a uniform circular motion. Usually, uniform motions will have a same velocity or same speed. But in the case of circular motion, here its direction is always changing. As you can see here the direction changed, again the direction changed, again the direction is changing, again it's changing, again it's changing, again. So here in circular motion, the direction keeps on changing. You know that velocity depends upon direction. If the direction is changing, velocity is changing. If velocity is changing, acceleration is changing. So here we know acceleration is equal to change in velocity by time. In all other types of motion, when it is a uniform motion, here you will have a same speed divided by time, you will get same acceleration. In this case also, you will get the same acceleration in numerical value, but the issue is its direction is keeping on changing. First maybe it is towards the south, then it will be towards southwest, then slightly it's always changing. So since the direction is always changing, uniform circular motion is an accelerated motion. Usually we'll be confused at the end. Why uniform circular motion is an accelerated motion? Here uniform circular motion is accelerated motion because the object's direction is keeping on changing every now and then. That's why it's accelerated motion. Let's see what we have studied till now. First of all, we describe what is motion. If an object is changing its position with time, then we'll say that the object is in motion. Then we'll always use a reference point to say whether the object is moving or not. Reference point is nothing but the point based on which we say whether the object is moving or not. Next is distance and displacement. Distance is the complete path covered by something. Displacement is the shortest distance between initial and final position. Distance is a scalar quantity. Displacement is a vector quantity. SI unit of distance is meter. SI displacement is also meter. Now, one main point here is distance cannot be zero, but displacement can be 0. When will it be 0? When the object returns back to the initial point itself then displacement can be 0. Next was uniform motion and non-uniform motion. If an object is covering equal distances in equal interval of time, then we'll call it as uniform motion. If an object is covering unequal distances in equal interval of time, then we'll call it as non-uniform motion. Next is speed and velocity. Speed is distance by time. We know distance is a scalar quantity. So speed is also a scalar quantity. SI unit of speed is meter per second, also represented as meter second raised to minus 1. Velocity is displacement by time. We know displacement is a vector quantity which has direction. So velocity is also a vector quantity. Its SI unit is also same as speed, that is meter per second, meter second raised to minus 1. Average speed is total distance by total time. We'll just add one total here, that's it. Now coming to average velocity, if initial velocity u and final velocity v are given to you, then add both and divide by 2. Take the average of it, you will get the average velocity. If they are not given, but you have an option to find out total displacement and total time, then you can find out the velocity like that also. Next is acceleration. Acceleration is also called rate of change of velocity. It is because time is the rate of change of velocity. Equation for acceleration is change in velocity by time. Remember that v should be taken first, that is final velocity minus initial velocity by the time taken. Here the SI unit of this is, we got the SI unit like this, velocity is SI unit divided by the SI unit of time, that is meter per second by second. We got meter per second square. It is represented like meter second raised to minus 2. Next one is the graph. Here first we discussed about distance time graph. In distance time graph we have 3 different varieties of graph. First one is object at rest. If the object is at rest, you will have a straight line parallel to the x-axis. In uniform motion, you will have a straight line like this. In non-uniform motion, you will have a curved line like this. From distance time graph, you will get the quantity that is speed. The slope of distance time graph gives you speed. Now going to the next type of graph, that is velocity time graph. In velocity time graph, you have 4 different types of graph. First one is straight line parallel to the x-axis. Don't be confused between the previous graph and this one. Here it is velocity time graph. Here the velocity is same. So you call it as uniform velocity or uniform speed or uniform motion. This graph stands for all of this. Now suppose if you have a line like this, then it is uniformly accelerated motion. Its speed is keeping on increasing. So it's uniformly accelerated motion. Suppose if you're keeping your hand on the accelerator and not taking it at all, then your vehicle speed will keep on increasing. That is this graph. Now suppose you're braking. When you're braking, the speed will get reduced. That is this graph where you have uniform retardation or you have negative acceleration. This graph stands for all of that. Then last type of graph is something like this, or you'll have some curved line like this and all. That graph is called non-uniform motion. From velocity time graph, you will get 2 things. The slope of the graph will give you the acceleration and the area under the graph will give you displacement. Going to the last one, we have equations of motion. The first equation is v is equal to u plus at. Next is s is equal to ut plus half at square. Then v square minus u square is equal to 2as. Last we have the uniform circular motion. Usually when the object covers equal distances in equal interval of time, it's called uniform motion. But in the case of circle, since the direction of the object is always changing, we call it as accelerated motion. If this is happening, if equal distance is covered in equal interval of time on a straight line, then we'll call it as uniform motion without any acceleration. But here in the case of circle, it's a special case because here the direction is always changing. It's not like this. Here if you see, it's a single direction, but here the direction is keeping on changing like this. That's why it's called accelerated motion. That's all in this chapter. We'll continue with the laws of motion chapter in the upcoming episode. Thank you.